a lot of times, and you came across this several times on your homework, where the conditional formulas are used and they're conditional statements even though they don't have the words given that in them. And I've given you 3 examples here, 2 of which you can see. I'll scroll down to the 3rd one in a minute. Looking at the first one, we've already recognized today that the order that the conditional is written matters. So we have to make sure that we know the order that the conditional is written. So April, tell me when you look at this first problem what the order of the conditional is. What comes first? Does female come first, or does store charge card come first? Actually, the charge card comes first, okay? And let me tell you why. Anytime so keywords that you want to be looking for, of is a way we can replace of with given that, okay? So, really? So given that, so it's what you're dividing by. Of the female population, or given that they were female, how many of them have a store card? So that's really what you're looking for in this particular case in number 1. So we're going to write charge card given that they're female. Okay? So that's what we're looking for here. Charge card given that they're nice. Charge card given that they're female. All right? Let's look at number 2. Different context. Where can the given that go here? It is conditional. What goes first? Cameron? I'm looking at number 2. That's okay. I'll come back to you on number 3. Okay? We want to find the probability of someone that tests positive for a disease doesn't actually have it. So which one comes first, the positive or the does not have the disease? Does not have the disease, and I'm going to write it this way if that's okay, disease complement. Is that all right? So they don't have the disease. What's the probability that those who tested positive, so of those that tested positive, given that they tested positive, we're looking for the probability that they didn't have the disease. Okay? How about number 3? Cameron, you want to address this one now? So what's the order here? Right, we're looking for the low gas mileage first. So low gas mileage, given that they had what kind of an engine? 6-liter engine. Okay? So even though the words given that might not be there, they still can be conditional statements. And so having to recognize that sometimes is a battle. And here's one of these examples. The last strategy, and I say this as the last strategy before next week's test. We've gone through a lot of strategies, slot diagrams, formulas, Venn diagrams, and now the last one is a tree diagram. Okay, contingency tables as well. And contingency tables and tree diagrams are often used one or the other. But I happen to be a fan of tree diagrams. They're very linear in thinking. So we're gonna look at this one. So I'd like for you to at least write this problem down, or you can print it off at home if you're not going to write it down, but at least read the problem. And I want you to identify the 2 variables that are listed. There has to be at least 2 variables for us to use a tree diagram. And that's kind of your hint. That's what you're doing. There's multi-stages of the probability. So I'm going to pause the recording for a minute, read it or write it down, and then I want you to identify the 2 different things that are happening here. 2 things. The first thing is what? They either have the disease or they don't. Would you agree with that? Okay. So that's going to be the first branch of our tree. They either have the disease or they do not have the disease. You can use a squiggle, you can use a little C, whichever you feel comfortable. Disease and not disease. We're also going to add the percentages here. It says that 5% of the population has a disease. Well, that means what percent don't have it? 95. And so you're going to write the probabilities there along the branches of the tree. Every branch, or set of branches, I should say, should add to 1. Okay? Each little cluster should add to be 1. Now, That's one thing that's happening. They either have the disease or they don't. What's the second thing that's happening? They either, somebody besides Cameron, I know Cameron knows, somebody else. They test positive or they don't. They test positive or negative. Would you agree with that? And so that actually happens whether you have the disease or don't have the disease. That's like the second stage of what's happening. It's the other variable. So let's add the percentages along these branches as well. It says here, the test has been developed, but sometimes has false readings, and so we're going to use our tree diagram to figure out somebody who tests positive but doesn't have the disease. That's like a false positive going on. Okay, so we want to figure out, based on this test, it says that 98% of those that have the disease test positive, and only 1 without test positive. So what's the false positive rate? It's going to be higher than you think. Just watch. So 98 of those with the disease. So I'm at the top branch. Those with the disease test positive. So 98% go here. What goes on the other branch? 0.02. Very good. 0.02. Because 2% of those with the disease test negative. All right, keep going. It says 1% of those without the disease. So now I'm on the lower branches. 1% test positive. How many without the disease test negative? 99%. Okay. So I have started my tree diagram. To finish the tree diagram, we actually have to go along the branches like this. We'll do it 4 times in this case. And we're going to fill in some, we're going to find the first one is the probability of those with the disease and test positive. They're independent events. Just because you have the disease, it has no effect on, you know, you can multiply them is my point. So we're going to do that. What is 0.05 times 0.98? You guys have your calculators out? Oh, I did divide. 0.05 times 0.98. I get 0.049. And you're going to do this across the way. We're also going to do the probability of disease and test negative. So we're going to multiply 0.05 times 0.02. And I get 0.001. And we're going to fill out the rest of the tree diagram. We're going to have the probability of disease and, no disease and positive, and the probability of no disease and negative. So we're going to multiply across the branches. 0.95 times 0.01, 0.0095, and then 0.95 times 0.99, 0.9405. In any tree diagram, one of the things that you can do is you can check to make sure that you've set it up correctly, because all of these things here, all of my ands should add to be 1. It's a way to check yourself. Did I miss a branch? Did I miss something up? Did I multiply incorrectly? It's a way for you to check your tree. Okay, they should add to be 1, and they do here. So let's use our tree diagram as a tool to answer the question. So let's go back to the question. Let's write in context what it's asking me to do. I want to find the probability that someone who tests positive does not have the disease. It's a given that. It's a conditional. Very good. What is the order of the condition? So someone who tests positive, so given that they test positive, what's the probability that they do not have the disease? Are we okay with that order of the conditional? That's half the battle. Now I'm going to use my formula. This is the probability of no disease and positive divided by the probability of positive. Do I have the numbers here? What's no disease and positive? Good, 0.0095. I found that already because I multiplied across my tree, right? What about the bottom? What about the denominator, though? What's the probability of positive? Nope. Yes. There's two ways to test positive. I can have the disease and test positive, or I can not have the disease and test positive. So I actually have to take these two numbers and add them together. Okay? And that's your denominator. So 0.049 plus 0.0095 becomes my denominator. And when I divide those things, let's see what I get. 0.1624. So the probability that someone who tests positive does not have the disease, that's the probability of a false positive reading, right? False positives. 16% of the time? Ah, that's scary, isn't it? When you read those percentages in the beginning, did you think that it was going to be that high at the end? Didn't seem that way. But believe it or not, it happens more than you think. Okay? So, what tells us in a problem that a tree is a good idea? How many did, well, maybe, but how did we create our branches? We had to have what going on? Two different outcomes, right? Two outcomes, two things that are happening. Most of the time, the question that's asked based on a tree diagram is a conditional. So if you're drawing a tree, most of the time your question will be a conditional, so you can look for that. Okay? Let's try one more, and then we'll be done for today. Okay, one more. So, I want you to read this problem, copy it down, print it off at home, whatever you want to do. The tree on this problem looks a little bit different than the one we just did. That's why I'm choosing to use this example. I want you to think about what are my outcomes, what couple of different things are happening here, how many branches do I need to have, okay? So I'm going to pause the recording for a second while you guys make those determinations, okay? There are two factors, if you want to think about an experiment from that perspective. It's the kind of drinker you are and what kind of accidents you have, okay? So there's still two variables. One of those variables happens to have three levels, though, okay? The kind of drinker you are, and this is a big problem in college, by the way. Binge drinking is it's a huge issue. So it's, real life example here. But in this situation, or in this problem, the kind of drinker you are happens to have three levels. So we'll start with three branches to our tree. You're a binge drinker. Let's hope you're never a binge drinker. You drink moderately, or you abstain entirely. Those are the three types of scenarios we have. We'll put the numbers in a minute. From there, the kind of drinker we have are the first, and what's the second type of situation? What's the second variable? The kind of accident. So you either are in an alcohol-related accident, or you're not in an alcohol-related accident. Would you agree with that? And each of these have the second branch. Okay? So let's continue to answer the questions. Or fill in the numbers. So it says here that 44% of college students engage in binge drinking. That's so high, it's scary to me. 37% drink moderately, and 19% abstain entirely. What should all of those add to be? 1. So you just want to check that, okay? You want to double check that that is true to make sure I didn't leave anything out. They do add to 1. Now we're going to move on to our second series of branches. It says among binge drinkers, so now I'm in the top, right? I'm in the top branch of my tree. 17% have been in an alcohol-related accident, which means how many have not? 83%, right? 0.83, because those also have to add to be 1. Question. You'd have to figure out where you made your mistake. Yeah, so that's a clue that you either drew the tree wrong or something happened. Okay, good question. Moderate, among the moderate drinkers, 9% have been in an accident, which means 91% have not. And then among the abstainers, none have had an alcohol-related accident, which means 1 or 100% have not. What do I need to continue to do? I've got to do all of my formulas, right? We're going to multiply. So I've got to find a lot of things here. Binge drinking and accident. Probability of binge drinking and no accident. Probability of moderate and accident. Probability of moderate and no accident. Probability of abstainer and accident. And probability of abstainer and no alcohol-related accident. So we need to find all these probabilities. I don't have them written here, so I'm just going to have to do the math along with you. Remember that you're going to go along your branches. So moderate and accident goes here. Those are what you're multiplying by. Whatever you're looking for. You're going to go along your branches and multiply to get what you're looking for. So I'm just going to go ahead and fill in what I think works. Double check my math. What should all these add up to be? 1. Do they? Can you check for me? Someone be willing to check? Okay. It's something you should check on your tree diagrams, okay? You want to just make sure that they do. So I have 3 questions I want us to answer. But before I move to the next page, I want to make sure you've got this down. We okay? All right, so here are the questions. Question number 1. What's the probability that a randomly selected college student will be a binge drinker who has had an alcohol-related accident? What kind of a question is this? Is this an and, an or a conditional? It's actually an and. We want to be a binge drinker and have an alcohol-related accident. Matthew? Binge drinker and accident is 0.0748. Okay, we've already found that number, right? This is here. So 0.0748. All right, how about number 2? What's the probability that a randomly selected student has had an alcohol-related accident? So we want the probability of accident. How do I find that? Say what? I got to add up all the accident ones. So which ones are the accident ones? All the ones that I am circling. Would you agree? Those are all the ones that you either have a binge drinker in an accident, moderate drinker in an accident, or abstain and have an accident. It's one of the 3. So 0.0748 and so hang on. 0.0748 plus 0.0333. And what'd you get, Matthew? That one? Okay, good. Good. All right, last question. What's the probability that a student who has had an alcohol-related accident is a binge drinker? What's this? This is a given that. This is a conditional one. So what's the order? They've had an alcohol-related accident. So given that they've had an accident, what's the probability that they are a binge drinker? So in context, isn't this the probability of binge drinker and accident divided by the probability of accident? Right? Guess what? By design, I've given you the answers here. Binge drinker and accident is 0.0748. That's my numerator. My denominator is the probability of accident, 0.1081. When I divide these, what happens? You get a pretty big number. Tell me what you get. 0.69 something. 0.692? 69% of students that have had an alcohol-related accident are binge drinkers. That's pretty high. Okay? But do you see how I used my tree diagram to be able to answer those questions? Okay? All right, so what's for homework? Your homework is going to be obviously to study for your quiz. I have put together some more problems for you to work on that I'd like to have you do between now and Monday. I am going to give the substitute an answer key to this so that they can give you the answers before you take your quiz. There will also be like this how you got the answers and whatever. Because you guys have a sub on Monday. Because I'll be in Baltimore. If not, yes, I am. But you are going to be turning this in, and you should have it done before you come. I would like for you to omit for now. We will come back and do them, but I want for you to omit problems 6 and 7. Okay? I should also tell you that number 3, can you look at number 3? That's going to, well, I just have you do it. That's fine. It's 20 cars is a lot of slots, is all I'm trying to tell you. I should have said like 3, but I didn't. 20 cars. It's a lot of slots. Okay, any questions on what's for homework, what's study quiz? I will be after school today till about 3 o'clock. If you wanted to stay and work on this assignment, that's fine. Otherwise, I'll see you guys next week.